Hi. Good afternoon, and I hope everyone had a nice lunch. I'm Namrata, and I'm an engineer at Workday. So today, I'd like to discuss several critical issues that I think every individual and organization should be aware of when it comes to sustainability of their businesses. Now, these are some of the insights that I've gathered working with data infrastructure and observability stack over the years. And since we only have 15 minutes, we'll keep it very brief and very precise. And if you'd like to deep dive into some of the concepts we'll talk about, there will be resources and links in the slides which will get released, or you can talk to me outside. So I like to think that we here are part of a community. And so today, I want you to think about the role that you can play as a member of the SRE community in saving the planet. Now, climate change has been a very important topic of conversation this year. So we've had record heat waves and droughts in many parts of the world. Now, that has made us all feel very helpless at times, and we've often wondered if there is something that we can do. So I'm here to tell you, well, it's not too late to do something about it, and there are continuous improvements being made on an industrial level, yet you as an individual, as part of an organization, have an important part to play. So this is basically a call for collective action to make your engineering more sustainable and reduce our carbon emissions. And the goal is not just to be carbon neutral, it is to be carbon negative. So to begin with, I'm quickly going to go over how monitoring and reporting of carbon emission happens and why this is important to the systems engineering domain. So in the coming years, it will be mandatory for businesses to report their carbon emissions, and this is as per the Paris Agreement of 2016. Now, currently, we have 3 categories which are used to determine these emissions. So we have Scope 1, which are your direct emissions, which is produced by the organization themselves by the use of fossil fuels. And then you have Scope 2, which are indirect emissions, which are basically the use of electricity and generated through energy consumption. And then you have Scope 3, which is basically everything else. It's your transportation, procurement, manufacturing, or somebody else's Scope 1 and Scope 2. Now, for SaaS-based companies, the main source of emission is based on computing, hardware manufacturing, and procurement, and data storage. So for the most part, the Scope 1 and Scope 2 are usually low. So now your Scope 1 and Scope 2 emissions could actually be higher, say if you're running your own data center, where it is not outsourced to Scope 3, sorry. So if you are hosting your infrastructure on one of the public clouds, it's actually seen that in the regions of Americas and Europe currently, since they use a lot more renewable energy to power these data centers, your Scope 3 emissions based on where you're running your infrastructure will be lower. But if you are running your data, so if you have your data centers in areas where there are significantly fewer renewable energy resources, your carbon emissions will be much higher, say, for example, in Asia. And we are expected to have some solutions for greener data centers in Asia in coming years. Now, like any problem, the first step to fixing it is to analyze the scope and the scale of it. And in this case, it means adding some form of carbon monitoring to your businesses. So we have AWS's customer carbon footprint, and you can find it in your billing console. Azure has Microsoft Sustainability Manager. And they're both market-based tools which calculate Scope 1 and Scope 2 emissions, which means it derives emission factors from the sale of energy. And GCP has carbon footprint tooling API, which is free, and it is a location-based Scope 1 and Scope 2 emissions reporting API, which means it's based on the average emissions intensity of the grids where consumption occurs. And currently, it's the most advanced data set available. So if you want to, design a workload optimization tool to reduce your emissions, this would be very, very handy. Now, there's also some open source ones. There's cloudcarbonfootprint.org. Green Software Foundation has a bunch of specifications which you can integrate in your systems. So it is necessary to enable some level of monitoring which could indicate the carbon cost of your IT spend, and you can even figure out how much power each storage class or service utilizes. And while these numbers are not an exact science, or sometimes they can paint a different picture of your accurate carbon emissions, but they are a good indicator of the trend of your carbon cost and can highlight the problem area. So once you know where the problem lies, you can really drill down on those components one by one. So now you understand where the emissions originate from, but there's one aspect of knowing the problems, and then there's another of knowing how to solve it. So you have to ask yourself, what are we going to do about these things? So there are two aspects that we're going to talk about today. So one is the resource utilization. And one thing which we often hear about is CPU wastage. So there's a lot of tooling available which can show us by the use of your metrics the number of idle or unused resources currently running on your infrastructure. Now, if it's just an EC2 instance which is running and it is underutilized or it's just idle for days and days, then you can basically slap a dollar figure on it and do a cost-based comparison. So that's very simple. I think many of us have done that. But there is also a carbon cost attached to it. So for example, there's this tool, and there's bunch of others like this. There's Climate IQ as well. They give you an approximate carbon cost of running your EC2 instance. Now, for an M4 large EC2 instance running in US East for 1 hour, if it's 40% underutilized, it's currently seen that the carbon emission of that is equivalent to driving 4 kilometers in a petrol car. That's one EC2 instance, mid-sized, for 1 hour. Now, when you apply scale to it, when you have large-scale infrastructure and you have replicas and shards and different development and staging environments, then this number really becomes very, very large. And this contributes very highly to the emissions of your organization and also adds to your cost of operations. So if you are an SRE who is motivated by having monetary value attached to the carbon emissions of your resources, you could use one of those carbon footprint estimators to monitor those values per instance or deployment. Green Software Foundation also has something called software carbon intensity, which is a model for carbon per unit of work. So you can fine-tune your API calls and transactions to reduce your carbon emissions there. And in terms of tooling, it is also noted that orchestration platforms such as Kubernetes or the scaling groups, platforms which basically treat your underlying pool of resources as fungible, are very good step for ensuring that your workloads are properly distributed and optimally utilized. One thing that I really quickly want to touch upon is the economies of scale and how data centers play a role into it. So big cloud providers and software vendors are actually able to invest more in advanced technologies which are designed to reduce electricity requirements and also cooling and power conditioning. So this is an important consideration, say, currently if your infrastructure is running on one of the older data centers, like US East 1, which is not super efficient. So you might find the newer machinery is better at utilizing power. And data centers utilizing renewable energy like the ones in Europe are particularly good at reducing your carbon cost at scale. So centralization into big cloud providers mean that instead of building many relatively smaller, inefficient data centers, and currently there are 8 million of them, we're building fewer, larger, and more efficient data centers. So you would observe that recently many big firms have migrated to public cloud as part of their long-term sustainability initiatives. So if you are debating currently whether or not you should move to public cloud, you should factor in the carbon offset of the said service provider and their contribution to net zero during procurement, maintenance, as well as end of life. And this is the last bit, and this is basically the second part of where we can make a change. And this is about data management and processes. This is something which is often overlooked when we talk about sustainability in software engineering. So in the last 2 decades, we've witnessed the copious amount of data every company wants to store. And they want to store your personal data, they want to store your usage, behavior, metrics, system data. But they also want to store it indefinitely, forever, on their servers, on this varied mix of data stores. And some of you here have helped design those very systems. But the data that we generate is itself a kind of digital pollution, a new kind of trash for the information age. Currently, this contributes to about 15% of our digital carbon footprint, and it is expected to be more than 40% by 2025. So now, everyone's hoarding more and more data, but how much of this data is actually being utilized? And why exactly is this concerning? So studies have shown that less than 10 to 15% of data accumulated by organizations is regularly used for some beneficial purpose. And the rest of it is just staying there. It's just not being utilized at all. So it's just trash. And I think we can all agree that the current standard of indefinite, unplanned data retention is bad. But it's not just for the carbon cost you can rack up, but also for the exposure to privacy, regulatory, and legal risk. So how do we solve this? Well, you have compliance, and nobody loves compliance. But still, it is a very necessary tool which can help us improve the controls of data flow. And as SREs, we sit at the very heart of information control. So by complying to these regulations, you can improve the control of data and the infrastructure for it, while also controlling the cost associated with the data that you're storing. So how does this help? We've seen that storing less data leads to a reduction of backend services like massive data stores, which reduces the cost of data ownership, all the while having a positive impact on your carbon reduction goals. And just to give a few figures, like reducing 1 terabyte of data on cloud, on SSD, considering all the backups and redundancy, can reduce your emissions equivalent to driving 55 kilometers in a car using petrol or diesel, which is, again, a very small figure when you consider it on a yearly basis, but again is amplified by scale. Now, in my experience as part of information lifecycle management, the archiving and disposing of data is usually forgotten about, and we stop at just usage. So identifying a way to automate data archiving and decommissioning processes as ongoing sweep in the future is really, really important. And starting with why do we need this data and collecting it is a better way to go about it. Now, we as SREs are ourselves very guilty of having infinite retention of pages and pages of metrics and dashboards. I sometimes feel that observability is like an afterthought of a system, and we end up inheriting a lot of legacy metrics which don't really make sense to us anymore, but probably made sense to somebody else years ago. So we could all do a bit better ourselves. So how? Well, you already know the answer to that, actually. It's by using the tools that you already are aware of, the SLIs, SLOs, and error budgets. So you have SLIs, which help you determine what those important metrics are, SLOs, which tell you if those metrics are measuring up to your expectations, and error budgets, which tell you when the underperformance of your system has become a bottleneck for your end users. And you currently are in a perfect position to lead this conversation between stakeholders and your teams to determine which metrics are important, why they matter, and discard the rest. So we currently, as SREs, are in a perfect position in many organizations to bring necessary people together and act on these things that we talked about today. So you could be an embedded SRE, part of more core infrastructure, data engineering, ML ops. It really doesn't matter. You can start anywhere. So you can monitor your carbon emissions, you can archive your data sets, you can optimize workloads for better resource utilization, you can deprecate unused infrastructure components, or move to public cloud if that suits your strategy. And if you feel this doesn't really change anything on an industrial level, well, you're part of the industry, and you make the industry. So you have to make the change, and if you don't do anything, then it really doesn't add up to anything. So I hope we all do our bit and hopefully take a little something from today and work towards our goal of reducing carbon emissions as we go forward. So thank you.